Okay, everybody. Tonight we're going to look at a continuation of our limiting reactants, and we're going to start looking at how we calculate the remaining excess reactant in a reaction. So the first part for us here is to first calculate our limiting and excess reactants and find our theoretical yield like we did the other night. So in this particular case, we're starting with 5 grams of each reactant. So we'll start with aluminum simply because it's first in the reaction. And we know, according to the periodic table, that the molar mass of aluminum is 26.98 grams for every 1 mole. Using the mole ratio, for every 2 moles of aluminum that react, 2 moles of aluminum oxide are produced. From there, we can use the molar mass of aluminum oxide, which happens to be 101.96 grams of aluminum oxide, to calculate the mass of aluminum oxide that can be made from 5 grams of aluminum. And when we do that math with proper sig figs, we get an answer of 18.9 grams of aluminum oxide. Now we repeat the same process for oxygen. We start with 5 grams of oxygen, and we're going to do the same exact thing. We know that there are 32 grams of oxygen for every 1 mole. And according to the reaction, for every 3 moles of oxygen that react, we make 2 moles of aluminum oxide. And to find out the mass, we use the molar mass again of aluminum oxide, 101.96 grams. And when we do this math, we get an answer with proper sig figs of 10.6 grams of aluminum oxide. From here we can identify our limiting reactant, excess reactant, and theoretical yield. So when we do that, we see that in comparing how much product can be made, 10.6 grams of aluminum oxide is much less. So this is going to be our theoretical yield. We can then identify oxygen as our limiting reactant, and aluminum is our excess reactant. So this is what we learned in lecture the other night. What we're learning tonight is the next step. How do we find out how much aluminum will be left over once the 10.6 grams of aluminum oxide are produced? In order to solve this part of the problem, we have to start with the theoretical yield. Okay? So we want to start with the theoretical yield. And we want to convert the theoretical yield, so let's take that, the theoretical yield, and convert it to the excess reactant to find out how much excess reactant we need. So that's what we're going to do next, okay? So our theoretical yield here is 10.6 grams of aluminum oxide. And we're going to use the molar mass of aluminum oxide. The nice thing about calculating excess reactants is that even though we have more conversions, all the math was done for us, or we already did all of the math while we were finding out who the limiting and who the excess reactants are. Now it's a matter of just combining everything in a different way. So here we'll use the molar mass that we calculated in the first problem with aluminum to be 101 26.96 grams of aluminum oxide for every 1 mole of aluminum oxide. And then we use the mole ratios. 2 moles of aluminum oxide are produced for every 2 moles of aluminum that react. We continue on. For every 1 mole of aluminum that reacts, 26.98 grams of aluminum react. That's our molar mass. When we do this math, we get 2.80 grams of aluminum are required. So this is how much gets used up. Okay. How much of the aluminum gets reacted right here, okay? Now to find out how much is left over, what do you think we do? If you guess subtract, you're absolutely correct. So let's take a look at how we do that. We have our starting amount, right? We started with 5 grams of aluminum. We're going to subtract how much we used, how much was consumed. We consumed, or will consume, 2.80 grams of aluminum. We end up subtracting the 2.8 grams from the 5.0 grams, and what's left will be 2.20 grams of aluminum, and we say they will remain. This is our final answer after all of this work. So, calculating excess reactants are not much more work than finding limiting reactant, excess reactant, and theoretical yield. It's one more stoichiometric calculation and then a quick subtraction. But this is how we calculate how much excess reactant will remain after the reaction is over. We're going to apply this to some problems tomorrow, specifically problem number 45. There's a few, it's an ABC problem, so we'll continue working on that tomorrow in class. Have a great evening.